Now we would like to solve this system of differential equations for x and y as functions of t. So our first step would be to change it to matrix form, and then after that what we would do is that we would find the eigenvalues of this matrix, okay, and after that we will look for the eigenvectors. So for the eigenvalues, first we calculate the characteristic polynomial, which is given by solving this determinant, okay, and if we are using the symbol lambda, then let's put -5 minus lambda, then I have -2, then I have -1, and then -4 minus lambda, right? Okay, so this determinant equals what? The determinant will be, just multiply the diagonals, it is only 2 by 2 matrix, and then take the difference, and here we go, we have this product minus -2 times -1 is 2. When we FOIL these, what do we get? We get 20 plus 9 lambda plus lambda square, right? So lambda plus lambda square, okay, sorry about that, minus 2, which equals how much? Lambda square plus 9 lambda, okay, as we had before, plus 18, right? Now all we have to do is to solve this characteristic equation, and the solutions will give us the eigenvalues. So when we look at the factors, what we have is that see, 18 is 6 times 3, and we get this characteristic polynomial factored as what? Lambda plus 6 times lambda plus 3, and set that equal to 0. So we have lambda equals -3 as one eigenvalue, all right, and lambda equals -6 as the other eigenvalue, all right, just as we did before, okay. So here we have -6. Now we shall go ahead and find eigenvalues corresponding to these eigenvectors. So an eigenvector of lambda equals -3 will say, let's take a symbol here, okay. So say we are taking our eigenvector as xy here, all right, so that will satisfy this equation. One moment please, let's make a matrix equation here, okay, and we will replace lambda by -3 because that's what we are looking at, all right. So here we have -3 again, so this has to be a solution of what? This matrix equation equals 0, 0. All right, so when we simplify it, what do we get? We get -2 here, and then -1 here, and both of them will lead to what? x plus y equals 0. So what will happen here? That y is negative x, okay, and a solution corresponding to lambda equals negative 3 is what? E to the negative 3t, and y is x, so we can take a vector, say 1, negative 1 corresponding to this. So this is a solution. All right, and notice this with e to the negative t here, and we have the two components satisfy this relationship, y equals negative x. So y equals negative x will give you a straight line solution. Okay. All right. So this will give a straight line solution, and I shall show that to you within a vector field in a few moments. Now we are going to find a solution corresponding to the eigenvalue lambda equals negative 6. So we'll take the same equation, just negative 3 changes to negative 6, and then what do we get here? We get this becomes a 1, negative 5 plus 1, and this becomes a 2. So what will happen here? We will have x minus 2y equals 0, or in other words, x equals what? 2y. So if we take y equals 1, what do we get? We get this, e to the negative 6t. Okay, let me just copy it here and replace it with the values. All right, so if I took, say, y equals 1, x becomes 2. Okay, so this is another solution. All right, and we have, and after that, what we are going to do is that if we have to write a general solution, then a general solution is going to look like what? We can just take a linear combination of these two linearly independent solutions. Okay, so now we shall write a general solution of the equation. Just take write xy and nxy, and then x and y both are functions of t, and here we have, which one was our first one? Right here I got a solution, then I have another linearly independent solution from this one. So combining these two, what we have, this is a general solution. Now notice this, that both the eigenvalues are negative, so the origin is going to be sink. If they were both positive, it would have been a source, and for different signs it would have been a saddle point. Now if we look at a vector field of this system, then you can see here you can see our straight line solution, y equals negative x, and this is what? This one is 2y equals x. All right, so let me know if you have any questions about it.